All right, this chapter is going to deal with alcohols, ethers, and amines. And so these are three different functional groups that we're going to talk about in this chapter. As far as chapter objectives go, it says by the end of the chapter, you should be able to name alcohols using the IUPAC naming system. You should be able to classify an alcohol as primary, secondary, or tertiary on the basis of their structural formulas. You should be able to talk about hydrogen bonding a little bit and talk about how that influences physical properties of alcohols. What else? Predict the products when alcohols react with different acids and bases. Write chemical equations for alcohol dehydration reactions, oxidation reactions. List some uses for alcohols besides consuming them. Then with ethers, you should be able to name some common ethers or use a common name to name an ether. You should be able to describe physical and chemical properties of ethers, assign common names to amines. So we'll look at amine nomenclature. You're going to be able to classify amines as being primary, secondary, or tertiary. What else? Predict the products when amines react with different acids and bases. So very important in chemistry. Talk about hydrogen bonding with respect to amines. So not only can alcohols hydrogen bond, but amines can as well. And then give give the uses of three different crucial biological amines. So let's start with nomenclature and classification of alcohols. And you should be able to recognize an alcohol by now when we have an OH group like this, okay, attached to some kind of carbon-based compound. We call that an alcohol. And this group here, just the OH group itself, oftentimes you'll hear me refer to that as the hydroxyl a hydroxyl group, so a hydroxyl group, and then the functional group is an alcohol. Anyhow, I'll probably use both of those. So just to get that straight before we get into it. And like I just said, what's an alcohol? Well, an alcohol is a compound that has a hydroxyl group connected to a hydrocarbon. Now, if we have a hydrocarbon, and so our group here represents a hydrocarbon and then our hydroxyl, we call that an alcohol, okay? And again, you heard me mention hydroxyl or hydroxy, same thing, it's just the OH functional group. But if instead of an alkyl group, you have an aromatic ring, okay? If you have an aromatic ring, right? Aromatic ring with a hydroxyl group attached to it. That is what we call a phenol. So a phenol is when your hydroxy group is attached to an aromatic ring. If it's attached to an alkyl group, we call it an alcohol. Now, you remember the structure of water. I mean, we've looked at it many, many times in chemistry class, okay? So this is the structure of water. We know it has a bent molecular geometry. If you want to just draw the Lewis structure of water, you could draw it like this, H2O, nothing wrong with that for just a Lewis structure. But we could condense this one bond here, and we could look at our water molecule as kind of being two parts, okay? And that's what you're seeing down here, right? They're kind of showing you or they're kind of showing that water, you can think of it as a proton and a hydroxy group, okay? So if we replace the proton in water with some kind of alkyl group, then we get an alcohol. If we replace the proton in water, if we replace that with an aromatic ring, then we end up with what? We end up with a phenol. So make sure you know the difference between an alcohol and a phenol. Again, alkyl group attached to your hydroxy, alcohol, aromatic ring attached to your hydroxy is going to be a phenol. All right, now how do you name an alcohol? Well, the simpler alcohols are often known by common names where you just list the alkyl group followed by the word alcohol. So if you know your 8 alkyl groups like methyl, ethyl, propyl, isopropyl, butyl, terbutyl, secbutyl, isobutyl, if you have any of those groups attached to your alcohol, your hydroxy group, you can just name it as the name of the alkyl group followed by the word alcohol. And you see some examples here. Okay, if you have a methyl group attached to your hydroxyl, right? This is just a methyl group. We would call it methyl alcohol, or you can call it methanol. Either one is fine. If you have an ethyl group attached to your hydroxyl, right, you can call it ethyl alcohol. And the common name for that is ethanol. If you have a propyl group, you can see where this is going, you would call it propyl alcohol. And if you had an isopropyl group, you would call it isopropyl alcohol, or isopropanol is fine too. Isopropanol, I should point out, this is rubbing alcohol. All right, rubbing alcohol, which is used to kill bacteria. Anyhow, this common naming convention quickly becomes unreasonable if we have some kind of alkyl group attached to our hydroxy that is not some kind of common name, right? If you have some kind of big group, well, you're not going to use a common name. So this is why we need a more systematic approach to naming alcohols, which was developed by the IUPAC, the International Union of Pure and Applied Chemistry. And so we're going to go over the rules for naming alcohols. Now, I just want to remind you, if you don't know this already, that ethyl alcohol, ethanol, is the alcohol that's found in alcoholic beverages. So I'll just put here ethyl, ethyl alcohol, which is also sometimes referred to as grain alcohol. I don't know if you can see that, but anyhow, grain alcohol. And so it says here different types of beers have different concentrations of alcohol. So some might be, as low as 2%, and some might go up to, I don't know, 7 or 8% for some of the really strong ones. All right, so what is that stepwise procedure that we use that's developed by the International Union of Pure and Applied Chemistry for naming alcohol? Step one, we're going to find the longest carbon chain like we did with an alkane. But just like we did with an alkene or an alkyne, we find the longest carbon chain that contains the hydroxy group. Okay, so we have to have the hydroxy group attached to that longest chain. Next, we're going to name the longest chain to which the hydroxy group is attached. The chain name is obtained by dropping the final E from the name of the hydrocarbon, and then we replace it with the suffix "-ol." So let's say we have, you know, hexane, right? We would be a hexanol. If we had an octane, it would be an octanol. If we had a nonane, what do you think? Nonanol, so on and so forth. We're going to locate the position of the hydroxy group, and we're going to provide a number for that in front of the name of the parent. And so we could have something like a 2-hexanol or a 3-hexanol, et cetera, et cetera. Locate and name any other groups. So 1-ethyl, 2-methyl, 3-chloro, all that kind of stuff. And then we combine everything. We combine the name and the location for other groups, the hydroxy group location, and the longest chain into the final name. And remember, all the groups that are not part of the longest chain, we list those in alphabetical order. Numbers and letters are separated by dashes, and if you have two numbers, we separate those by a comma. Now, alcohols containing two hydroxy groups, we call those diols, right? We know the prefix di represents two, so two alcohols, diols, right? I think it kind of stands to reason there. A very commonly found diol would be this one here. So if I just draw the structure here, this is called ethylene glycol. Ethylene glycol. And this is one of the major components found in automobile antifreeze. The IUPAC nomenclature rules for these compounds are essentially the same as those for naming single hydroxy compounds, except the ending would be diol, right? And if you had three hydroxyl groups, it would end with triol or tetrol, et cetera, et cetera. Now, if we have a substituted phenol, they are named as derivatives of phenol, right? So you need to memorize what the structure of phenol is. It's shown here. And so you can see in this compound, we have a phenol in it, right? And we automatically assume that the carbon that has the hydroxy group attached to it is number one. So 1, 2, 3, 4. So this would be 4-bromophenol. You could also call this compound para-bromophenol since it's a disubstituted aromatic ring. And for this one over here, there's our phenol. And so we would call that 2,4,6-tribromophenol. All right, let's see if we can name some alcohols here according to the IUPAC system. So the first one, you can see the longest chain that contains the hydroxyl is going to be 1, 2, 3, 4, 5 carbons like this. So that means since the hydroxyl group is going to be on carbon number 1, 1, 2, 3, 4, 5. Okay. So this is going to be a 1-pentanol. And then you can see that we have a group. It's an ethyl group. It's on carbon number 2 like this. So this would be 2-ethyl 1-pentanol. So we'll put that in here. Just fix my slides here. So this would be 2-ethyl 1-pentanol. Okay, so 2-ethyl 1-pentanol for the first one. For the second one, you can see that it has a phenol in it. right? Here's my phenol. I'll put that in the red circle like this. So that means that carbon number one is the one that has the hydroxyl attached to it. But if we go counterclockwise in this case, that would give the lowest possible number for the ethyl, right? If we went counterclockwise, it would end up with a number of 6. Well, 2 is lower than 6. And so this is going to be a 2-ethyl phenol. So 2-ethyl, 2-ethyl phenol. All right. So 2-ethyl phenol will be this guy. Maybe I'll put it on top here. Okay. And then the last one, you can see the longest carbon chain in this one has 3 carbons. So this is some kind of propane. And we have hydroxyl groups on carbons 1, 2, and 3. So this would be 1, 2, 3 propane triol. So 1, 2, 3 propane triol, like that. So 1, 2, 3 propane triol. And I should point out that this compound, this last compound here, this compound actually has a common name too, which is glycerol, which has many uses. Glycerol comes from the hydrolysis of fat. But anyhow, the reason they showed some cough syrup on here, so this is supposed to be cough syrup being poured into the spoon, is because glycerol is found in cough syrups. All right, classification of alcohols. If you remember at the introduction of this video, I said you're going to learn how to classify alcohols as primary, secondary, and tertiary. And it's relatively straightforward. For a primary alcohol, it's going to be an alcohol in which the hydroxy group is attached to CH3 or to a carbon attached to only one other carbon atom. So something that I learned when I was a student, and it doesn't spell this out in your textbook, but if you have, let's say, something that looks like this, CH2OH, the carbon that is directly attached to the hydroxy group, okay, sometimes we refer to that as the carbonyl carbon. Now, again, I don't think that term is used in your textbook, but the carbonyl carbon. So if I refer to a carbonyl carbon, it's the one attached directly to the hydroxy group. And so the way we differentiate primary, secondary, and tertiary alcohols is by looking at the carbonyl carbon. If I zoom in here, if your carbonyl carbon, and I'll highlight it for a primary, if your carbonyl carbon is attached to only one carbon group, that makes it primary. So you can see this carbonyl carbon is the one attached to the hydroxy. It's attached to only one carbon. That makes a primary alcohol. If your carbonyl carbon, you can see this carbon that I have highlighted in green is attached to the hydroxy. If it's attached to 2 carbons like this one is here, right, 2 carbons, then it's going to be secondary, and you can guess where this is going. If your carbonyl carbon is attached to 1, 2, 3 carbons, just like it is here in this example, then it's going to be a tertiary alcohol. So all we have to do is look at the carbon attached directly to the oxygen. The number of carbons that it's attached to dictates whether the alcohol is primary, secondary, or tertiary. I repeat, if the carbon attached to the oxygen of your alcohol is attached to 1 carbon, it's a primary alcohol. If it's attached to 2, it's a secondary alcohol. And if it's attached to 3, it's a tertiary alcohol. And so question 9.2 says propylene glycol is used as a solvent in many pharmaceutical drugs that are insoluble in water. Classify each of the 2 hydroxyl groups in propylene glycol as being primary, secondary, or tertiary. Well, we'll start with this one here. I'll highlight it in yellow. This is my carbonyl carbon. Well, how many carbons is it attached to? It's attached to 1, 2 carbons. So that tells you that this alcohol is a secondary alcohol. Now I'm just going to erase my scribbles that I put here, okay, and I'll highlight the other alcohol in green. Okay, well, here's my carbonyl carbon. How many carbons is it directly attached to? It's only attached to 1. And so that means that this hydroxyl that I have highlighted in green would be a primary alcohol. And so that's all there is to do for identifying an alcohol as being primary, secondary, or tertiary.